So today we're going to focus on system of inequalities, which is very similar to system of equations, except system of equations either had one solution, no solution, or an infinite amount of solutions. System of inequalities will always have multiple solutions unless it has no solutions, because we're looking for the overlap of the two or more inequalities that we draw. And the biggest thing is we want to test points out. Okay, so whatever region you think, we want to test the points out, and they have to work. A solution will work for all of the inequalities. So we want to make sure that we test it into both of them. And again, we want to not test the points that are on the boundary line. We want to test some other points in the actual shaded region. So let's work on our first example. So there are two line inequalities. So we have y is less than or equal to negative x plus 5. We have y is greater than 2/3 x minus 1. And if you want to pause the video and try to graph those on your own, that's fine. I've already graphed them for us. Right, so the top equation is in blue. So we see 5, down 1 over 1, down 1 over 1. And the other equation we see is in orange. Okay, so again, so we'll see negative 1, then we'll see up to 1, 2, and then over 3. Notice that the orange equation is going to be dashed because we don't have a line underneath. The blue equation is solid because we do have a line underneath. Okay, so the whole reason of why I wanted you guys to graph with just lines is for the sake of argument of seeing where this overlap is going to be. So let's first focus on the blue. So we see the blue is less than. So I know I'm going to be shading below my graph. So I'm just going to make one or two just quick shades. So now I'm going to be below there. So now I'm going to look above the orange. And above the orange is somewhere over here. So I see that there is a crosshatch happening right here. So I think all my answers are going to be in this region. And again, notice this test point, 0, 0, just happens to also be in our cross, the overlapping, right? So let's make a test point. So test point. So I'm going to try 0, 0. It has to work in both of the equations. So plug it into the first equation. So 0 is less than or equal to, negative 0 is just 0. So 0 plus 5. Is 0 smaller than 5? That's true. Okay, let's try the second equation. So 0 is less than 0 times 2/3, which is 0. Sorry, 0 is greater than, I should say. Is 0 greater than negative 1? That is correct. So I know that I can go ahead and I can erase these random lines that I drew over here because they are not part of my situation. So I know that below my blue would have been over here, and we want to include everything over here, and then above my orange would have been here. Okay, and so we're going to see all that. We don't want to include the above of the orange over here because it wouldn't satisfy the blue line. We don't want to include anything below over here because it wouldn't satisfy your orange. So again, it has to satisfy both of your inequalities. Okay. So let's try this example. So example number 2. Y is less than x plus 2. Y is less than or equal to 10 minus 3x. Sorry, 3/4 x. So go ahead, pause the video and see if you guys can at least draw the two lines. Okay, so the first thing I would have done is I just would have flip-flopped the 10 and the negative 3x. And again, the top one is going to be my blue line. This one's going to be my orange line. And I've already graphed them for you right here. So, so my orange line started at 10 and it went down 3, 1, 2, 3, and then over 4, down 3 over 4, solid line, because we have a line underneath. This one started at positive 2, up 1 over 1, up 1 over 1. And again, it's dashed because we are missing that line underneath. Okay, so now what I want to do is I want to focus on where I see an overlap. Okay, so it said I want it to be below my blue line. So below my blue line would be somewhere down here. So I'm just going to make a few marks, very light, below, right there, one there. And then I want to be below my orange. Now, again, I'm trying to think. No, nothing over here technically it is below my orange, but I don't see any overlap with my blue. So I want to focus over here, and I see some overlap that's going to happen with my blue and my orange, right? So I see that overlap, which means that this line that I randomly drew probably doesn't need to be there. Again, I want to test some points out. Just so happens that my wonderful test point 0, 0 is in the region. One more time. So test point 0, 0. So test it into the first equation. So 0 is less than 0 plus 2. 0 is less than 2. True statement. Okay, we knew that. Number 2 is 0 less than or equal to 10 minus 0, because negative 3/4 times 0 is 0. 10 is definitely smaller, or sorry, 0 is definitely smaller than 10. That is a true statement. So I can go ahead and I can kind of darken these lines a little bit more. So I know it's going to be all in here. So again, you're looking for that overlap. Again, if you wanted to make them a little darker, that's fine. Again, make sure that you are drawing things, you're drawing your lines, and it does include all of your area, right? So notice that I extend both my blue and my orange way past where my graph is going to be, just so I can see all of the solutions, the solution area. Again, you want to be able to read. I should be able to pick any point out and be like, oh, I know exactly what point that is. If you make it too dark, that might be a little bit difficult to see. Okay, so that was our second example with 2 lines. So now let's get a little bit more challenging. Let's throw in an exponential with a line. So go ahead and pause the video and try this one on your own. Okay, so again, that is a 0.5. So again, technically, all of that is being raised to the power of x. So remember, a -6 means that we're never actually going to get to -6. I've already graphed this for you. So 0.5 is the same thing as 1/2. So we're going to see a decay graph. It's in blue. It is solid. And if you notice 1, 2, 3, 4, 1, 2, 3, 4, 5, we're never going to get to that 6. So notice that my graph never crosses it. So there is that asymptote at 6. And again, if you just made a table of points, you would have seen that, right? Plug in 0, you would have gotten 1, and 1 minus 6 gives you 5. So again, everything's just been shifted down 6. Okay, for the top equation, or sorry, the second equation, this would be an orange. You have a y-intercept at 0 and down 2 over 1, down 2 over 1. Notice that I dashed it this time because we don't see a line underneath. Okay, so now let's focus on what this means. So I want to be greater than both of them, essentially. So when I look at this equation, where is greater than my blue graph? I'm greater than over here. I'm greater than right here. I'm greater than over here. So there's a lot of places that I have to be greater than. But I also have to be greater than my orange graph, which means I'm greater down over here. That's not going to make sense. So greater than just where my orange graph and my blue graph are going to lie is going to be here. Right? So notice that everywhere that I have that line, it's above both my orange and my blue graph. I don't want to go down over here And again, I don't want to include any point over here. Now notice that 0, 0 is on the line. It's on the orange line, which means nothing on the orange line is actually a point because it's dashed. So I have to pick a different number. So let's go ahead and I'm just going to pick, let's pick that point right here. So what is that? 0, 2. So test my point. 0, 2. So the first one, I don't need to type in y. Just plug in a 2 instead. So 2 greater than 0.5 to the power of 0 minus 6. Well, 2 is in fact larger than 1 minus 6, which gives me 5. So I knew that that was a true statement. So let's try the second one. So 2 is going to be larger than negative 2 times 0, which is 0. So 2 is in fact larger than 0. So that's a true statement. So again, I tested just that one point. Again, if you want to test a few other points to make sure that they work in both of the equations, that's perfectly fine. But that's it. That's where your two overlaps happen to be. Okay, so let's try one more. This will be our last example. Okay, so go ahead and pause the video. Try to do everything. Change it to y is equal to mx plus b for that bottom equation. Try to graph it. Try to see where the shading is. Try to test a point out and all of that. Okay, so we're back and let's just walk through this carefully. So my top equation is exponential. It's not going to be it's not going to be solid. It's going to be dashed. And the second equation will be solid. So I changed that already over here. You see my work for y, divide everything by 4. And I have my line of equation. So this is what my equation, my line and my exponential graph is going to look like. Now, to be above my, I'm going to be above my exponential, which means I'm going to shade above over here. So a couple lines, just throw that up there. And then over here, I'm going to be below my orange, which means that I'd be down here, but that doesn't make sense. I'm going to be over here, which does make sense. And so I see that I'm kind of, I'm not going to be able to test any point that has a 0 in it, which is fine. So I'm just going to pick one point. Let's pick this point right here. So it looks like it's in between both my my line and my exponential graph. So what point is that? 1, 2, 3. So this will be, we're going to test the point. -3, 1. Okay, so my first equation was the y is greater than 2x. So y is greater than 2 to the power of x. So 2 to the power of -3, which will be 1 is greater than a 1/8. That is a true statement. 1 is definitely greater than 1/8. So let's try the second equation out. So the second equation is x plus 4 times y is less than 4. So it's going to look like this. So x plus 4 times y. So -3 plus 4. And -3 plus 4 is 1. And 1 is definitely smaller than 4. Worked out. So I'm going to go back up here. I'm going to take away these random lines that I drew over there. And so I know that my shading will be in between those two lines. Okay.